Hello and welcome to another episode of Invalid Entry. My name is James Taylor and today we're going to be drawing snowflakes, fractal snowflakes. So first of all I was going to explain what they are with a bit of paper. I'm sorry this is zooming and zooming out. I think it's having problems with the amount of blank white. So we're going to draw some things. Basically a Koche snowflake is 3 Koche curves put together. So basically we have 3 points and we just draw the lines in there. And the idea behind a Koche line is that you basically have a line, that would be order 0. And then order 1 is take the same coordinates, work out a third the way along, like that, and break into thirds. Then you basically, instead of drawing this middle segment, you would draw the same distance out to there, and that will be the order 1 type. And then you can say, well, basically each of these are line segments in their own rights, so we can do the same thing. We can basically take one of those points that we've got on the first one, you've got a point there, and then you can basically work out a third the way along of each segment, and connect those up with like that. As long as you always go to the same side, you end up with what is starting to be a snowflake. Now if you then do that with 3 lines over here back to back, what you end up with on the first order is basically a Star of David type thing going on. And then the next layer down, when you do this one, you'd actually end up with what looks like, and I always get a little bit confused with my angles here. Oh dear. There you go. That's your second order Koche snowflake. But we're not going to do it by hand, we're going to do it with programming code. Now the trick for this basically is to have a generic formula to draw a line. So and we're going to use recursion, which you shouldn't really use recursion, you should use loops and things, but we're not going to recurse far enough down this for it to be a problem with the computer. We're going to recurse 4 or 5. Going beyond 4 or 5, you start getting into pixel issues where your lines will be shorter than 1 pixel. And you just end up with a black blur. So basically what we're going to do is we're going to come up with the generic formula to work out, given 2 input coordinates, work out this coordinate, and also this coordinate. And trust me, that is the tricky one to work out. These ones are simple. You basically start off with a coordinate of start and end. You basically work out the height, and you do the same with the horizontal as well. You work out the height, you divide the height by 3, and then that basically gives you those heights, and then you add on one, whichever way around you do it, you add on that to actually give your down. Do the same with the horizontal, those are the coordinates. This coordinate is a little bit trickier because actually it is halfway along at 90 degrees out, and it's a fixed distance. You can either do this as a triangle or this, and you can work out what the distance is. Now this isn't 1/3, I can tell you that now, because this distance here is 1/3, where u is the distance between the two. So what I'm going to do is I'm going to go away and work that maths out quickly and be right back to you once I have. Right, I went and did the maths, and I also double checked online, and it was the same answer, although my order of operation slightly out. Basically, as I said, the first point is a third the way down plus the AX, and the second point is a third the way up plus the AX. And the same for the last one is actually, you can imagine it as a third the way minus or 2/3 the way. So the first and last point, the easy one. The hard one is the middle coordinate, which is the halfway point. That's easy to calculate. Plus this bit, which is the square root of 3/6. And it's because you can basically take the units, you can divide the units into 6, and then use Pythag to work out the triangles. And you simplify it down, and it comes out like this. So that is the coordinates programmed in. Given a start and end location, I'm then returning 4 coordinate pairs. So there's actually a bunch of numbers here. I broke it out here nice and easy so I can print off all the numbers without doing start 1, start 0. I can program in. So what I have here is a bit of a script which basically is just going to make a 500 by 500 square. And it's not going to show you anything at all. There you go, absolutely nothing. Because I'm not drawing anything. If I, at the moment now, decide to get some coordinates, remember I'm doing this at like 3 ticks a second at the moment, which is fine, which is what it is. What I'm actually going to program first of all is a function, because I want to draw recursively. And again, recursion is a bit naughty, but so basically my coordinates, chords equals calculate star chords, and I'm going to pass it in two pairs of numbers. So I'm going to pass it in like 10, 10, and then I'm going to pass it in 490, 490, just as across the screen, top left to bottom right. And that's going to give me back an array of coordinates. So I'm going to def chord, draw chords, surface, and a chords array to actually draw. I'm also going to pass in here depth, because I'm going to go straight for recursion. Depth equals depth minus 1 minus equals 1. Let's do it actually minus 1. So last equals chords. The first coordinate I want to be last. I'm going to skip the first stage. So for chord in chords from the first place onwards, so I don't have to, because otherwise you get the weirdness from the first one. If depth equals 0, then we want to draw the actual line. So line, I've imported python.draw line. Line, it's going to go on this surf. I'm actually going to change that name from surface to surf, so I don't have a conflict with Pygame later. 255, 255, 255. It's not an alpha layer, so I don't need an extra number there. I want to go from the last chord to the chord. And then I also want to make sure I go last equals the chord, so it resets the last position, so I'm not drawing from the start every time. However, the depth is not equal to 0, then the new chords is equal to calc star locations last chord, so it'll actually nip in there and it will do that, and then draw chords new chords depth, which of course is depth minus 1. When you do recursion, make sure you get that minusing at the top, and you'll make sure you also have this sort of edge case, otherwise it will recurse forever and you have to kill the program in the process. So chords equals that, and then I'm going to kick this off by saying draw chords, chords. I'm going to start just with a 1 in there, so it will just draw the first layer. And I've missed a colon here, another colon there. So the first colon is basically saying from the first index to the end. I don't need to put an end value in there. It will basically, it's a shortcut. Missing argument depth, because I called surface. It needs to be past the surface there, and that means I also probably missed the surface there. There we go. There you go. That's the first order snowflake. Very nice and clear. And what we can now do very quickly is step up to a 2, and we should get our second order snowflake like that, and we can start stepping up. Now what I'm actually going to do is put a little counter here. I've already got my counter already set up. Up equals true. So what we're going to do here is we're going to say if yep, we are going to do this. So if up, I'm thinking this through as I go, and so it's going with counter plus equals 1. If the counter is greater than 5. Now, if you put it more than 5, basically it will take so long to process a frame, but also you won't see any more detail because you'll be already at 1 pixel depth. Be amazed how few steps it's going to take. Up equals false, and then else. If it's not up, then you go to counter minus equal 1, and then if counter equals 1, up equals true. So it's going to basically count up and count down to 5, back down to 1, back to 5, and then I'm going to change that there to counter. So what we'll now do is we should now get an animation going, and that's the start of our snowflake. You can see as I get to 5, if I went to 6, you just wouldn't be able to see unless I made the picture much bigger. And the point about fractals is you don't need to make the picture bigger. That is now a snowflake. Now ideally what I actually want to do is not go from 10, 10, 490, 490, but instead have 3 of these things. It's 500 by 500, so I should be able to work out the midpoint here quite easily. And it's going to go to 490, 490, and then this one's going to go from 490, 490 to... I realise this is going to go inside out, by the way, and I'm going to do that on purpose to begin with. So from 490, 490 to 490 to 10, 490. This isn't going to be equilateral. I read as well. In fact, I'm going to need to come in a lot from there. I just realised that as well. So I'm going to go to 300, 300. And I'm going to bring that, no, I can stay at 10 for the moment. 490, 490 is going to go from 300, 300 to 100. 100. I really messed this calculation up. To 250, 10. I have completely missed this calculation up, but it will give us effectively not a star. Excellent. Also, because I need to put one of those in after each one of those, right? You can see here very clearly not a star, but also they're going inwards on themselves. So the reason for that is because I did the coordinates backwards. So you've got to be careful if you go inwards on itself, it basically makes there's a car logo. Is it Mitsubishi? So all I'm going to do is make it go around the circle in the opposite direction, and it should now generate me a very lopsided snowflake. So I'm going to go away and work out there you go, very lopsided snowflake. But as you can see there, it is a star. It's as good a star as my Christmas star on top of the nativity screen. Oh, sorry, the Advent screen. But there you go. That is today's video, all done and dusted. And next time we'll sort this out a little bit nicer and do a bit of different rendering on these, and maybe render it in a different order, or piece it together rather than just going up and down in such snowflakes. Yeah, if you like this, please hit like, please subscribe, please leave a comment if you've got any suggestions or ideas. And tomorrow we'll see where we get to tomorrow. I think we've got something special planned for tomorrow, so I will see you all then.